Again, I got a little distracted, then the phone actually left. Actually, had a malfunction, so to say, and I have to continue the video. As we were saying, to reiterate, each fuse is responsible for its system. Again, a parasitic draw is something over time. Let's say you can only draw a half an amp. I'm drawing 2 amps. That's much too much. I don't expect the fuses to be blown. I don't expect to go and measure a short to ground, because that would blow the fuse. So let's differentiate between, do I have a short to ground, a dead short, which is 0 ohm, or do I have something that's just draining the battery? Again, to reiterate, the best way, I said, you could put a voltmeter on a very low millivolt scale. But to see the difference in values is sometimes a little more difficult to see. The best way of measuring something is putting a current meter, a clamp like I made a video on, or opening up. You can always open up the fuse, take the battery, take off the positive, and put it in series, which I made videos about. Or I could take out a fuse. Right? I put my amp meter, because the amp meter goes in series. So I open the circuit, I break the circuit, and I put my amp meter. However, keep in mind one thing. This is rated at 15 amps. My multimeter might be rated at 10 amps. More than that, I'll blow the fuse on the meter. So keep that in mind. If I'm measuring 2 amps, I'll put my multimeter right here. Easy to open, easy access. I'll open it up. 3 amp. How will I know? I won't know until I actually put the multimeter there. So if I put the multimeter over there, and I measure, and let's say the circuit is drawing 14 amps, that's not good. It'll blow the fuse on the meter. It's only rated at 10 amps. That's why it's the best thing to open this up, the positive, and put the meter in series with it. Like I said, I made videos about that. That will show you the draw. So if I'm down to 9 volts on the battery and I'm drawing 5 amps or 6 amps, obviously that's a lot. If I'm not drawing anything or much less, obviously, that's because a fuse has blown. If a fuse has blown, I'll be drawing less current. So we have to understand this, what we're talking about. The system over here, like I said, let's start diagnosing and trying to troubleshoot. If this is blown over here at 15 amps, look where it's coming from. Through another fuse. Where is this fuse coming from? From another fuse, the main fuse. This is rated 175 amps, so that's a lot, obviously. That's a lot, obviously. This is rated at 40 amps. This is rated at 15 amps. So if I have a draw or a short, and and my current draw is 17 amps, it'll blow this. But it's not enough to blow this. Certainly not enough to blow this. If my current draw is 50 amps, which is pretty unlikely, right? Pretty unlikely. So anyway, 50 amps will blow this one. Not this, not this. It'll get to this one before this one. What happens if I do measure a very low ohms from this point to this point? In other words, we said we're drawing too much current over here. We have 9 amps, 10 amps. Now we're stuck. Look at all the systems that go through this node or branch. We have to individually try to understand or analyze the system. If we're talking about, again, we're talking about a blown fuse, easy. We look at the system that it's protecting. If I go and I put my meter over there, and I happen to be looking at it and this fuse is blown, obviously I'm dealing with fuel injectors, I'm dealing with modules, I'm dealing with this. Anything is possible. I could lift up the connectors or try to unplug the modules to see if the excessive current goes away right? But if the fuse is blown, how can they do that? Well, you could put a circuit breaker or another protective device because you don't want to keep on blowing fuses. So if I do that, if something is rated higher than this, right, what should I do? I could put ohms to ground. Forget about current. Measure from here to here with ohms. See when the ohms, the resistance goes higher. How am I doing that? By disconnecting either the connectors or the modules. That's not easy to get to sometimes, believe me. Now, if this is the blown, guess what? I'm not going to crank because the PCM gives the ground to these, connect and controls the ground for the ignition control module, which I made many videos about. Let's say I blow the fuse over here. We're not dealing with parasitic draw. We're dealing with a fuse. Can I still crank? Yeah. Look, these are intact. These are intact. So this, I can still, my ignition control module works, fuel injectors. However, this system, that is a secondary air injection system, will have flaws. It will not work. This is where it injects air, almost like recycling air into the cylinders. So I can still crank. If I'm still cranking, that means this fuse is good. That means this fuse is good. That means this fuse is good. Do I take a voltmeter? No. I have a block diagram right here to tell me. Do I have to measure 12 volts here? Do I have to measure 12 volts here? Do I have to measure 12 volts here? Or if the alternator is on 14 volts? No. Because I know this is cranking. That must mean the fuel injectors are working. PCM is controlling the grounds, and this is working. Is it working the way it's supposed to with the fuel air ratio? That's another question. But I know I'm cranking, so I know these fuses are good. Let's go down here. I measure the fuse over here. This is the mass airflow sensor. It tells you how much air going in. EVAP solenoids responsible for transferring or the air, the vapor that comes out from the fuel tank goes to the canister, the charcoal canister. I can still crank. If this is blown, I go and I measure the fuses. This is blown. This is still good. This is still good. This is still good. So I still have engine cranking. So the short must be over here, right? Oxygen sensor, and look how it's rated at 20 amps, right? More than this, more than even this. So if I go, like I said, I do it the old-fashioned way, and I just, like the mechanics do it, I test all the fuses, and I come to this fuse. This is blown. That must tell me something over here, the heated oxygen sensor, is the problem. Why? Because this is blown. That must mean this still is operating, and this still is good. So I have nothing to do with this system. That's why I said this, an outline or a system block diagram, as it's called, gives you a quick look when you find the problem of a blown fuse or something, what the fuse is, which system that fuse is responsible for, and you can work that way backwards. So therefore, if this fuse is blown, 40 amp fuse, if this fuse is blown, this is not working, obviously. Fuel injector is not working. This is going to here. It's going to here. However, you have to ask yourself, if this is blown, is the headlights come on? I can still, without cranking, I can still put the headlights on, as low as it is. That's where you have to understand the importance of a block diagram. Again, parasitic draw, I can do it both ways also. Parasitic draw, we're not blowing fuses. However, the voltage went down to 10 volts to 9 volts. Probably the lights will not come on because it's too low. The instrument cluster panel, which is the gauges, also will be too low, so those will not work. Right away, that tells me, you know what? I'm drawing very low. I'm drawing, my battery voltage is very, very low. Less than 11 volts. I can't even turn on the lights. My dashboard doesn't even work. So therefore, like I said, you could put your meter right here is the best place. I would put a multimeter, like I said, in the place of a fuse, but that multimeter is rated at 10 amps. Anything more than that will blow it. Like I said, if I'm drawing 5 amps, I can put it over here. But how do I know I'm drawing 5 amps? First I have to put the meter. That's taking a chance. Best way, put in a series with, take out the positive, take out the negative. You can also measure from the positive when you have it disconnected of ohms to ground to see how much the resistance is. So therefore, if I measure too much current, now I have to start playing. Let me take out this fuse, which is responsible for all this in one shot. But first look at the block diagram. Don't just pull out fuses like many mechanics do. Look at the block diagram. I have a parasitic load, 9 volts. It went down to 9 volts. What can draw that much current over time? I go over here. Can this draw current? I'll have to disconnect this fuse. I'll have to disconnect this fuse. I'll have to disconnect this fuse. But look what it's operating. Mass airflow sensor. If this fuse was blown, I can still have this operating. Might not be the right air-fuel ratio because this is an input to the computer. How much air is coming in, and it adjusts then the fuel. Might not be right, like we said. Still, this is still crank. Again, a parasitic load. I'm drawing too much current. I'm drawing, let's say, 9 amps, 10 amps. That's too much. One by one, I have to try to find a common branch or the fuses in the line and see where that fuse is connected to. It could be anywhere. It could be the lights, obviously. It could be the accessory. It could be a theft deterrent system, a security system, anything, right? So therefore, one by one, we take out the fuse. That gives me the system. And then I work individually to the connectors. I go over here. But keep in mind one thing. If I go and I take out this fuse, let's say, again, we have 9 amps, 10 amps being drawn. Why? Because I put the meter over here in series with the positive from the battery, then to the positive lead. So in other words, the battery, the multimeter, the positive went here, and the negative went to the one that the cable that I just took off. I'm putting in series, and I measure 9, 10 amps. If I pull out this one, what is that going to tell me? All of this is connected. That's not going to help. So now where's the problem? So if I take this out, obviously, then the draw will not be drawn. Why? Because I took out all the systems at one time. That doesn't make sense to do that. So you can't just pull fuses like many mechanics do. This is in charge of everything. If I don't have this, I don't have this, I don't have this, I don't have this, I don't have this. All of this is coming from here. So therefore, pulling out this main fuse will tell me nothing. Tell me something in this system or this system, this system, this system is a problem. We know that. We have to limit it down to something closer than that. Pulling out this fuse also. If I pull out this fuse and the draw will go away, obviously it will, because all the systems are connected through this. It's a common fuse. That doesn't tell me anything. If I take out this fuse, okay, now this won't work. Only this won't work. Now maybe, okay, now I'm getting somewhere. If I pull out this fuse, now maybe I'm getting somewhere. Why? Because only this won't work. This is responsible for this system. At least I'm limiting the systems by pulling out the fuse. If I pull out these individual fuses or these individual fuses, I'm worried about this system, not this. But what I'm getting to is if I pull out these two main fuses, I'm pulling out everything. What is that going to help me? So try to get to a smaller system from the block diagram, here or here or here or here. You're not accomplishing anything by taking out this one, which is controlling everything, obviously. And I'm going to make more videos. Actually, so anyway, please subscribe to both of my channels, Joe Electronic Schematics, which is for, I guess, students. I was asked for from students going to electronic schools to make videos for them, and also for automotive diagnostics. I think the automotive world needs More trained people in electronics. Mechanics there are plenty of, but there's not enough work for them. Electronics is computerized, and if you know electronics, you could be a valuable asset in the automotive world. Everything is computerized. So again, please subscribe to Automotive Electronic Schematics by Joseph. And I hope you enjoyed this. Please leave comments. Always welcome. Always trying to improve quality of videos. And I hope to see you next time. Thank you.